Okay, so the other day we looked at determining which case we have, which tells us how many triangles we have. If you have angle, angle, side, or angle, side, angle, then you can only have one triangle. If we have side, side, angle, we have to look at, is it acute or obtuse? And then from there, we look at the situation that we have with the, what?
Scenario.
Well, yeah, I was going to say situation. I was like scenario, and then I was like, ah. Anyways, so we're going to look at obtuse or acute, look at what we have, and then go from there with if we need to find H, if it's acute, and all the things. I'm only going to find H if I absolutely have to, if it doesn't meet one of the things in my table. So you're probably going to want to have your table close by. I have mine here, so I can just but obviously it won't necessarily show up. So we stopped at 16. So these were the ones where they drew a triangle for you. Obviously, if they've drawn a triangle for you, then there can only be one triangle, right? Yeah. So the next set of problems, they just tell you values. And so you're going to have to look at those. I would draw the triangle to see what situation we're dealing with that as well, and then we'll solve for them. Some of the triangles have no solution and some have two, so we'll get into what those look like as well. So 18, I've got angle A is 73 degrees. Side A is 18, and I'm actually going to set this up like I would to solve everything, and side B is 11, so that way I don't have to write it again, because work smarter, not harder. Okay, so I see that I have two sides and I have one angle, so basically, without even having to draw it, I know that then I have to have which scenario? Side, side, angle. So I'm going to set up my triangle this way, and it's possible that this triangle doesn't exist, but I'm going to set it up so that I can visually see it. So the angle that you're given is always going to go, just to keep it like the table. I'm not saying it has to be this way, but if not, you're going to get confused. In the bottom left corner, so this is angle A, which is 73 degrees. Side A has to be over here, which is 18. The other side length that you're given has to be the one that is touching it. So 11, or side B has to be there. And then obviously its angles go opposite of it. So this is B, this is C, and then this is little c. All right, so the first thing I'm going to do is I'm going to say, okay, well, I know I've got side-side angle, so now I need to determine, is the angle I'm given acute or obtuse? So what is 73 degrees?
Acute.
It's acute, so that means that now, since they've given me A and B, which is what my table was in the notes, I'm looking at A compared to B. So is A greater than or equal to B? Yes. So that means that I have one triangle, I don't need to find H. Okay, if this was not the scenario, then my only other option would be to find H and then determine which situation I'm dealing with. So I like to write A is greater than or equal to B, so one triangle, just so that I know what I'm solving for. So then I'm going to come down here. The first thing, I have to have at least one piece of information to solve, so the only thing I can solve for at the moment is angle B. So law of sines, bless you, sine of B over side B, which is 11, equals the sine of 73 over 18. We're going to multiply by 11, so that's going to put the 11 up here, and then we're going to use the stuff that we had in 13.4. I'm going to take the inverse of this, so I like to do this all in one step so I don't have to write it all over again. So the inverse sine of 11 sine 73 over 18. Now, again, make sure, in case you've done other stuff, make sure your calculator's in the correct mode. You need to be in degree mode for all the triangle problems. I'm going to also show you, because I don't think I showed it to you the other day just because we were kind of short on time, but I'm going to show you how to put in a fraction to your calculator in case, I mean, I've probably shown you before, but in case you've forgotten. All right, I'm in degree mode, so I'm good. All right, so we're going to hit second sign, which is going to give us the inverse. And then once you do that, hit alpha and then hit y equals, and you're going to see options pop up here. But the very first one is n/d, so that's numerator over denominator. So I'm going to do that, and it's going to bring up a fraction bar for me to use. So I've got 11 sine 73. Make sure you close that parentheses there on top. And then on the bottom, we put 18. You don't really, I mean, you can close that bigger one at the end, but you don't have to. And so you can do it this way, and it'll solve it for you to give you angle B. Otherwise, you just have to be really careful with parentheses when plugging stuff in. What?
They should also just use the divide symbol.
Yes, but you have to be really careful and watch for use parentheses with how you do it, or it won't necessarily take it up the whole thing. The other thing you could do is just do the inside, and then you could do the inverse sign of second answer, and it would also do it for you. So as long as whatever method you're doing is giving you the right answers, that's fine. This is just, in my opinion, a little bit easier to make sure that you have everything typed in correctly. All right, so angle B is, we're going to round to the nearest whole number on everything. So we're going to say 36 degrees. So then now what can I find? How did I do that?
180 minus 73 minus 36.
Yep, 180 minus 73 minus 36. Did you say 71? So 71 degrees. And then now I can use law of sines again to find side C. We'll just use the flipped version of it. And again, just to reiterate from the other day, use the given information. Don't use B. Now, obviously, if you did B wrong, your C is going to be wrong as well. But use the given information as a general rule, so that way you have less chance of getting something wrong, right? So we'll have C over the sine of 71 equals 18 over the sine of 73. So then multiply by the sine of 71. So C is equal to 18 times the sine of 71 over the sine of 73. Now, just kind of as like guessing if my answer is correct, I should expect an answer that's somewhere relatively near 18, because sine of 71 and sine of 73, while they're off by 2 degrees, they're very close, so they're almost going to cancel each other. So just kind of be aware of that your answer should be in that general vicinity. But anyways, what do we get for that?
18.
You said 18, right? Okay. So that would be my answer. Now, if you remember stuff from geometry about your sides and your angles, your smallest angle should have the smallest side, your biggest angle should have the biggest side. And that's still true. The reason, kind of like what I was just talking about, that C is 18, even though the angle is different from angle A, is just because we've rounded. Okay? So, I mean, within reason, like you shouldn't have C is 19 with an angle that's smaller than your other angle. But if it's the same value, it's because of rounding. Okay? But that's going to be something you're going to want to watch out for as you do problems and stuff like that. So, questions on that one? Okay. Let's see. 22. Angle A is 55 degrees, angle B is 64 degrees, and side C is 44. I keep flipping this. I'm trying to do this so I can, since I wrote this way this time for some reason, I'm trying to just fill in this thing. Wait, side C was 34. Got sidetracked. Okay. I don't know why I wrote this one sideways. Just roll with me on it. All right, so You said this one is what? Angle, side, angle. This side has to be between these two angles. So, angle, side, angle. Ultimately, doesn't really matter if you get that part right unless the question's specifically asking you for that piece of information. But this would be angle, side, angle. So how many triangles does that mean?
1.
Yep, 1. That situation, there's only ever 1. So, I'm gonna set up a triangle here. Sometimes when it's like angle, side, angle, I don't necessarily draw it. I will always draw it with side, angle, side, or not side, angle, side. That's law of cosine. Side, side, angle. There we go. So, doesn't really matter where I put these values here. But, like I said, I usually don't even draw it for these ones, but if you want to see it, that's what it would look like. All right, so what's the easiest piece of information to solve for right now?
Angle C.
Angle C. Do 180 minus 55 minus 64.
61.
So 61 degrees.
Oh my gosh.
So again, just kind of to think through what my final answer should look like. B should have the largest side. A should have the smallest side. So just, things to check as you're going through these problems. So it really doesn't make a difference. Do you want to solve for A or B first?
A.
A, sure. Sounds good. So I've got A over the sine of 55 is equal to, now obviously on this one I didn't have 2 pieces of given information, but I only have one other thing that I have all the information for, so I have no choice but to use C. So we've got 34 over the sine of 61. So then we just need to multiply by the sine of 55. So I've got A is 34 times the sine of 55 over the sine of 61. So we got side A is 32. Which makes sense. That's less than side C. So then I'm going to do B. Again, I would, even though technically both A and C have a piece of information that I found, I should be pretty confident when I'm finding just the third angle. So I would still use C over using A. If you use A, nothing wrong with that, but I'm going to use C for it because that's essentially all given information. So I've got B over the sine of 64 is equal to 34 over the sine of 61. So B equals 34 sine of 64 over the sine of 61. Did I already hear an answer for that? 35. Yep. So again, those values make sense there. All the angles are relatively similar. Side lengths being similar lengths all makes sense. 24. Angle C is 98 degrees, side C is 29, and side A is 33. It is a side-side angle.
So
Yep.
one triangle. That's A is B. Wrong. It's no triangle. Because C is the relevant side.
Yes, C is the side that I'm actually looking at. So in our situation of what we were looking at, in your notes, you were given angle A, side A, and side B. So we were looking at A compared to B. However, in this situation, we're given side and angle C and then side A. So we're actually looking at C compared to A. Okay, so I don't even really need to draw this triangle because it's no triangle. But as far as my chart goes, it's obtuse because it's greater than 90. So I'm looking at C compared to B. C is less than or equal to B. So you would need to write that C is less than or equal to A in this situation. And then you would tell me no triangle. So I think I mentioned this the other day, but part of showing your work, if it's a no triangle problem or whatever, or on the ones I just tell you to say, you know, what situation you have and how many triangles you have, unless it's like angle, side, angle, or what is it, angle, angle, side. Unless it's one of those two situations, like you need to have something there explaining why it is what it is, because we obviously have 6 possible situations or scenarios with side, side, angle. Um, $26. Angle B is 21 degrees, side B is 17, and side C is 32. All right, so I'm looking at, what just happened? I think it's trying to do something. Yep, so I'm looking at, in this case, B compared to C, okay, as far as things go. So I've got on here, looking at B compared to C. Well, B is not greater than or equal to C. It's less than, so that means I need to find H. Formula for H is going to be C sine B, so it's the side that doesn't go at the angle that you were given. So I usually write down the sine of the angle, and then that's when I decide what my other side length is for that, just to kind of help. So remember, with H, we're always going to go 1 decimal place past, because sometimes it might just be slightly bigger or slightly smaller. So we're always going to go 1 decimal place past. So we've got 32 sine of 21. And what does that give us?
11.5.
So that means that H is less than B is less than C. So what scenario do I have there? Yep, 2 triangles. So, part of the reason, well, one, I kind of forgot to write this the other way, but we're actually going to be setting up and solving 2 totally separate triangles, okay? Now, can 2 triangles exist at the exact same time? No. This is saying I have 2 possible triangles that can come up here. Okay, so I'm going to do my best to kind of draw a visual for you of what this would look like, and then we'll actually solve it. So I've got triangle here. Okay, this is B, this is side B, side C. I mean, this is angle C, angle A, and side A. So this is my big triangle here. Okay, this is my first triangle of what could happen. Now, if you remember in the notes, I kind of showed this being swung around like this. And so my other triangle actually is occurring somewhere in here. Okay, where this is going to become angle C. This is still side B. Technically the same length. My triangle is just not proportionate. And then this is my modified side A over here. Okay. So I actually have, let's see if I can draw this. I have my big triangle, and then I have this little tiny triangle over here, or my 2 triangles. So the first one I am solving for is this one. And then I'm going to solve for this one. We use 1 to solve 2. This is going to be the hardest problems in the whole section. I'm usually relatively nice to you on quizzes and tests. The other thing I would tell you is, not always, but most of the time, the amount of space provided is proportionate to how many solutions a question will have. If I give you not a whole lot of space, it's probably a good hint it's not 2 triangles. So just be aware of that. All right, so I'm solving for the big triangle first. So I'm going to come down here, or underneath triangle 1, I'm going to write I'm going to set up my stuff here, and then we'll do it again for this one on this side. I'll just do it I'll do it in a different color. All right, so angle B was 21 degrees. Side B was 17, and side C was 32. So these things within my triangles can never change, okay? That is straight up given information. That will also be the case over here for triangle 2. So if you want to go ahead and write in the stuff for triangle 2, we can write the stuff that we know for a fact, which is what was given to me. The other values are what will be changing. All right, so I'm solving for triangle 1 first. So the only thing I can solve for at the moment is angle C. So I've got over here, I'm going to just write this that I'm solving for triangle 1. So angle C is going to be the sine of C over 32 equals the sine of 21 over 17. I'm going to multiply by 32, and then I'm going to take the inverse. So C is the inverse sine of 32 sine of 21 over 17. So it's 42 degrees. So 42 degrees is what goes there. What? Okay, yep, so I'm going to find angle A by doing 180 minus 42 minus 21. So that's 117. So 117 is there, and then now I can solve for side A. So we're going to have A over the sine of 117 is equal to, what was my given information? B. 17 over the sine of 21. So A equals 17 sine of 117 over the sine of 21. So 42. Again, I just put a degree symbol on that. So again, those side lengths make sense. Now, solving for triangle 2 is actually much easier, but you have to pay attention to what we're looking for. Okay? So, I've already told you that the information that was given does not change. The next thing that I'm going to do is I am going to find this angle here is changing to this angle here. So in most cases, this isn't always true, but in most cases this angle is acute. So this is angle C. And so I have to find this angle over here, okay? Which is a lot of times going to become obtuse. Now, again, that's probably like 70% of the time that's what's going to happen. So to do that, we are going to take, to find triangle 2, I'm going to switch colors here. We're going to take angle C is going to be, so it's the bottom right angle is what we're finding now. 180 minus the, I usually say acute angle, but we're just going to say whatever angle C was from triangle 1. So it was 42, and we're going to subtract that off. So 138 is our angle C here. Forgot to put the degree symbol there. So now I can find angle A by doing 180 minus 138 minus angle B was 21. And what do I get when I do that? So it is also 21 degrees. Now, because these ended up being exactly the same, what should I expect to see here?
17.
It's also going to be 17. Just to see the work, we would have A over the sine of 21 equals 17 over the sine of 21. Obviously, when I multiply this, The sine of 21s are going to cancel. And so we would get 17. But just so that you can see the work, it won't always come out to be that way. They aren't always going to be identical. This one just happens to be that way. So, triangle 1, triangle 2.
It's not that bad.
Yeah, we just have area left. All right, the last stuff in this section is area, which is probably the easiest stuff in this section, as long as you know your formulas. So, you're going to need to know, I told you last week, you're going to need to know those 6 things to determine how many triangles you have, right, for the side-side angle case. And then you obviously need to know the law of sines formula, which hopefully is already ingrained in your brain. That's the easy formula. And so then the next thing we have is area. So area is, these should have been in your notes as well, but 1/2 AB sine C, or were these all in your notes? Or 1/2 AC sine B, or 1/2 BC sine A. These are your 3 formulas. All you really need to know is it's half of whatever 2 sides are given times the sine of whatever angle was given. They're going to only give you the 3 pieces of information you need for these area problems. The area problems that go with the law of cosines problems are going to give you a totally different set of information. So really just memorize one of these formulas and you're good to go. Okay, but you're going to need to have this memorized as well. Now, what I normally do is I'll have you write the formulas like on the top of your paper. It might actually be a question. It could be extra credit. Could be an actual question worth points where like each formula is 1 point or something like that. But you'll bring it up to me and let me check them so that way you don't go through the entire quiz using a wrong formula and that be the only reason that you got the questions wrong. It is really unfortunate. I've had that happen before and I'm like, ooh. So, 34. Just going to do like 2 of these probably. We've got angle C is 96 degrees. Side A is 7 and side B is 15.
So, AB, wait, 1/2 AB sine C.
Yep. So we've got 1/2 times 7 times 15 times the sine of the angle, so sine of 96. Again, obviously make sure you're in degree mode. Obviously, if you've been doing stuff in your calculator, you're already in degree mode. I'm just pointing that out so that when you get to the quiz or the test that you know what you're doing. So 52. And if you put units squared, that's fine. These ones, they don't actually do that when they give you the answers in the book, so I don't care. I'm not going to be picky about it, but if you want to. If they give you units, obviously we would need to deal with that, but they didn't. Huh? Yeah. So I said these are the easiest problems in the whole section. All right, we'll do one more just to make sure with different stuff given to us. Angle B is 60 degrees, A is 19, and C is 14. So it's 1/2 the 2 side lengths times the sine of the angle. So we've got 1/2 times 19 times 14 times the sine of 60.
114.
Oh, 14. Bless you.
15.
The 115. Again, the book's going to go to 1 decimal place. I'm fine with us just saying nearest whole number for everything in this section with the exception of H. 1 decimal place past whatever they give us on that. All right, any questions on those?
Not in this moment.
Okay. Because I have a feeling that there's going to be questions and confusion, I'm going to give us a work day on this tomorrow.
That's what I was hoping.
If we finish early tomorrow, then we might start the next section. But in addition, so you're just going to add this onto the paper that you did yesterday. We're going to have 19, 21, 25, 27 is just finding the error in what they did, and then 31 and 35.
I'll let you know. I'm feeling a little...
Now, I'm going to tell you, At least one of those problems has 2 triangles. But I'm not going to tell you which one. So there's only a couple minutes left, but tomorrow will be a work day. That way, if you get stuck, you have questions, you can ask me or a classmate. But you still need to have your 13.6 notes done for tomorrow because you'll need them on Thursday. So I think most of you already did them, but in case you didn't, just make sure you do because you're going to have them because you're going to need those formulas for the stuff on Thursday.